AI doesn't understand words by reading them like you do. It turned them into numbers. That sounds strange, but it's the reason AI can tell that kitten is closer to cat than to track. When you see a sentence like "the kitten sat on the sofa," you picture the scene. An AI system starts somewhere else. It breaks the sentence into pieces, turns those pieces into patterns of numbers, and asks one simple question: what is this close to? That is where embeddings come in. An embedding is a way to turn meaning into numbers. Take the word kitten. Inside an AI model, that word becomes a list of values. Not one number and not a dictionary definition, but a pattern. Those numbers are not meant for humans to read directly. They are useful because similar ideas create similar patterns. Kitten is close to cat. Dog is related, but a little different. Car and truck are much further away. Real models use hundreds or thousands of numbers, but the mental model is simple. Those numbers are a compressed shape of the idea. A useful way to imagine embeddings is as a map. Not a map of places, but a map of meaning. On this map, words and phrases become points. Kitten lands near cat. It also lands near dog because they are all animals. But it doesn't land near truck. A truck belongs to a different region of the map. Real embeddings have many more dimensions that we can draw on screen, but the visual idea still works. Close points mean similar ideas. Far points mean different ideas. This is the core idea. Embeddings turn meaning into distance. Now imagine you search for tiny cat. A keyword search might look for those exact words. An embedding search does something more flexible. It turns the query into a point on the same map and then asks, what is nearby? Tiny cat lands close to kitten and cat. It doesn't land close to track. Not because the spelling matches, because the idea is close. That's why embeddings are useful for search, recommendations, memory, and many AI features that need to find related things. Here is a practical example. Someone searches a help center for "How do I stop my subscription?" The best answer might not use those exact words. One article might say "Cancel my plan." Another might say "End subscription." Another might say "Close account." To a strict keyword system, those can look like different phrases. To an embedding system, they are close together. They express the same intention. That is the real value. Embeddings help software find the same idea, even when people use different words. But embeddings are not magic. They are learned from patterns in data. They compress those patterns into numbers, and that makes them useful, not imperfect. Context matters as well. Take the word apple. In "I ate an apple," the meaning points towards fruit. In "I bought an Apple laptop," the meaning points towards technology. The same word can move to a different region depending on the words around it. That is why AI can be surprisingly good at matching what you meant but still make mistakes. This is not understanding exactly like a person. It is estimating which meanings are close. So the pipeline looks like this. Start with text. The model turns the text into numbers. Those numbers place the text somewhere on a meaning map. Then the system compares distance and finds the nearest matches. That's what an embedding is, a numerical representation of meaning. The big idea is not the math. The big idea is distance. When two words, phrases, or documents mean similar things, their embeddings are close together. When they mean different things, their embeddings are far apart. Once you understand that, AI search, memory, recommendations, retrieval, and chatbots become much easier to reason about. So if you remember one sentence, make it this. Embeddings turn meaning into numbers, so AI can compare ideas by distance. That simple idea sits underneath AI search, recommendations, memory, RAG, and many modern chatbots. It is why AI can sometimes understand what you meant even when you didn't say it exactly. Not magic, just meaning turned into a map. Dmitry explains AI. AI explained clearly.